All right, week 14, what we're doing is Bootcamp week 1, because if you're not aware, Mathcounts chapter is in 3 weeks. Okay, 3 weeks. So that's not a lot of time left. And at this point, you should start upping up your game, okay? This is the time where you should start ramping up your studying, which is why we're doing like a sort of boot camp. We're not going to cover new things. We're going to do rigorous review of what we did last semester. So, and along with that, we're going to extend some of the topics that we've learned. All right. So this is the first week of bootcamp. We will be doing like bootcamp all the way up until the chapter competition. All right. So if you're new, here's something about me. In 8th grade, which was 2 years ago, it's 2021 now. In 8th grade, I did math counts. Okay. I'm not just like any random person who's just telling you what to do. I did math counts. In chapter that year, I was 10th place individual, and my team got 2nd place. Okay. And then at state the same year, I got 8th place, 3rd place team. Okay, I don't know how I got 10th place at chapter and then 8th place at state, but that's just how it worked. So that's my background to reassure you that I am experienced in this realm. Okay, so today's topics, I usually like to summarize what we're going to do today. We're going to do some general prep for the contest. I'm going to tell you what your plan should be for the next 4 weeks. Okay, we got 4 weeks until the competition. I'm going to tell you the plan. What do you need to do before the contest? And then we're going to do a boot camp for algebra. Okay, so generally in the Mathcounts competition, there's like 5 main focus points you have to do. You have algebra. That's not a very good color. Algebra, we have number theory, geometry, combinatorics, and logic. 5 focus areas. If you took all the questions on a Mathcounts competition and you put them, you'll be able to put them in one of these 5 categories. Okay. So today we will be doing algebra for the second half of the class. And for the next few lessons before the competition, we will do number theory, geometry, and combinatorics. You don't need to know what those are right now, but most of you should be from last semester, so you should know what that is. But we will be going over these in more detail as well for the next 3 classes. And the logic part, you can't really train that. I can't really give you a lesson on how to be logical. It's more of a thing that you have to gain through practice. Okay. So that's what we're doing today. We're going to do general prep for the contest. That's why I'm giving this general prep now, so you can plan out your next 3 weeks to prepare yourself for the competition. Okay. All right, so let's first review the Mathcounts season looks like. So this is October when you're doing the school round. Okay. You've already passed that, fortunately, or hopefully you've already passed that. That's why you're here. You've passed the school round. You're going to chapter now. So chapter is the first elimination round. It's the one that you're going to compete with other kids from different schools. And this is chapter. All right, you're going to go to chapter. And then the top 20% at chapter or the top in school. All right, if you're the top 20% of scorers or the top person in your whole school. All right, so this pretty much guarantees that one kid from every school is going to go to the next round. And the next round is chapter invitational. In past competitions, this was not a round that existed, but I'm assuming they're doing that now to I don't know, to get just have another filter to sort kids out. And at chapter invitational, the top 10 to 20% are going to go to state. So I think it's the top 15% go to state. And then when you go to state, there are actually 56 state competitions because they include like Puerto Rico and other territories. So the top four in state, that's pretty hard to get. Top 4 in state go to nationals. And at nationals, they crown the champion. Okay, that's basically how the season's going to go. So top 4 at state goes to nationals. So what that means is when I got 8th at state, I missed the national mark. So that's where I stopped in 8th grade. I got to here, and then I couldn't go farther. Okay. So now here's a list of the dates you have to look out for. The chapter round is February 5th, which is in 3 weeks, from 12 p.m. to February 6th at 12 p.m. So this is basically a time range where you can take the test. It depends on your school, really. This is just the range of time in which your school can choose one of these times to conduct the test, and you'll do it then, okay? The chapter round is the only one with like a time interval for you to take it in. Like you have 24 hours to take the test. That's basically chapter. And then on February 25th, there's the chapter invitational. It goes on at precisely 6 p.m. You have to take it at 6 p.m. Okay? Say the same thing, March 25th at 6 p.m. exact. And right now, they're still saying that the nationals is going to be in person, but it's probably going to switch online. Okay? Any questions about these dates? These dates, maybe take a screenshot, understand when you need to look out for. So the first competition is in 3 weeks, chapter. Okay. Now here's like the general tips. What should you do for a competition? The first thing you should do, just do problems. You have to go crazy with problems. Okay, do practice problems. No matter how much I tell you the concepts and the ideas and the math and the formulas, no matter how much I tell you that, you have to do problems. You have to do a ton of problems. And I think the reason I got better at state was because I went crazy with problems, okay? I literally did like 3 hours of problems a day, which I don't recommend that. Get me clear, I don't recommend to do like 3 hours of problems a day. But that is the most important thing you got to do. Do problems. Do a lot of problems. Okay, so I have 3 resources here that I can provide you. I have the problems from last semester. So all in all, I had 153 problems from all the homeworks from last semester. So if you haven't done those yet, especially if you're new, I highly recommend to go through that packet, okay? Or go through each video individually, go through the worksheet, and if there's anything that you're confused about, you can go back into the video and learn about the concepts. Okay, so that's the first resource. We also got the Mathcounts website, the official Mathcounts website. Over there, there's a ton of past Mathcounts competitions from past years, and take those as good practice as well. And then we have these 2 resources, which is Alchemist and Mathcounts Trainer. So these 2 are on the AOPS website. I'm sure a lot of you know this already. You have to go to aops.com. And this is where you can get these 2 resources. When I was in 8th grade, I went crazy on both of these, right? These were the ones where I really did all the problems. There are tons of problems in there. If you've used all of these, then do Alchemist and Mathcounts Trainer, okay? So that's like your third option. If you've run out of problems for the first two options, the last option you can, there's like unlimited amount of problems. There's like 1 million, and I don't think you'll ever be able to finish them. And then while you do the problems, compile a notebook of relevant formulas. And that's what I'm going to go through essentially for the next few weeks. And I'm going to tell you exactly what formulas you need to remember. Like these are things that you have to understand before you go into the competition. And then like make a notebook with all of those things. Okay, so you can study it right before. Now, what do you do during the competition? So if you're not familiar with the competition, we've got 2 main types of competition inside each round. So we've got the sprint round. Essentially, these are 2 different tests. So we got the sprint round and the target round. The sprint round, you got 40 minutes to do 30 problems. The target round, I think they give you 8 minutes for 2 problems. Okay, the target round gives you 8 minutes for 2 problems. And then they repeat this like 4 times. For a target round, they give you 2 problems. They give you 8 minutes to do those 2 problems. They take the problems away. Then you do 2 more with 8 minutes. Then you do 2 more with 8 minutes, 2 more with 8 minutes. So you do that 4 times, the target round. So the problems are basically broken up. You have 8 minutes for each pair of problems. Okay, so because the target round is broken up like that, there's not really that much time management involved. But the sprint round is you need to time yourself very well there. So you got 40 minutes, which means that for the first 10 problems, take 5 minutes on this. All right. If it's taking more than 5 minutes, I mean, try not to spend more than 5 minutes on them. Hopefully it shouldn't take more than 5 minutes because all of those should be very straightforward and simple. And for 10 to 20, those should take 10 minutes. So this one is really variable. This one should be based on you. Okay. How much time you spend on the problems from 10 to 20, they're really based on the person. If you're like a 6th grader, you're not very experienced yet, you should maybe spend 20 minutes on this middle section. Okay. Because the chances are, if these are pretty difficult, you're probably not going to get anything, or maybe just 1 or 2 for the last 10 problems. So for those, it's just not worth your time if you're not really at that level yet. And that's totally fine because Mathcounts competition, we have 6th graders all the way to 8th graders, and that gap is pretty large. So it's totally fine if you're taking longer than usual on these 10 problems. And that's completely expected of you. So if you're like in 6th grade or something, I recommend spending more time focusing on getting these 10 problems right. So maybe spend 20 or maybe 30 minutes on those 10 problems. Make sure you get those right. But if you're more advanced, 7th, 8th grade, you have more experience with Mathcounts, it should only take 10 minutes for these. And then you spend the bulk of your time focusing on the last 10 problems. Okay, and this is where it really matters. How much, basically for all like the top 12 people in the competition, they generally get all of these right, or maybe miss 1 or 2. Okay, for the top 12 people, this is basically what happens. They get all of them, or they only miss 1 or 2. And what really differentiates between them is how many of those last 10 problems they get right. So if you're at that level and you want to move from maybe 10th place to 5th place in that level, then you got to spend a lot of your time on the last 10 problems. Okay, and then leave 5 minutes at the end to check your answers. That's really important. And if this might seem a little too hard for you right now, this is because the people in the top 12, they're usually all 8th graders. They're almost always all 8th graders. So if you're in 6th grade, don't worry. It's really hard for a 6th grader to get in that level. So totally fine. By the time you're in 8th grade, then you will be at that level for sure. Okay. And while you're doing the problems, make sure your answers are in the correct form. This is really important. Sometimes you do the math correct, and then like for some reason the problem will say you have to give your answer as a decimal, right? If you say, oh, the answer is 1/2, then this is wrong. If you were supposed to write 0.5 and you wrote 1/2, you're wrong. Okay, that's the sad part, and a lot of people get problems wrong because of that. So make sure you're giving your answers in the right form. And when you're checking your answers, while you do your work, while you're like doing the problems the first time, make sure your work is like orderly and easily written so you can go back later and review it. It's easier to check your answers. Okay. And then while you're doing the problems, make sure that your answer makes sense. So I'm going to go over that. You can do like a self-check, really quick self-check to make sure your answer actually fits the context of the problem. Okay. So that's something you can do while you're doing the problem. So first, does your answer make sense? If it's a word problem, is the answer reasonable, right? If the problem says, oh, how many apples did Bob buy? Like, for example, and then if you got like 1 million or 1 billion or 1 trillion as your answer, it's probably wrong, right? Probably. If your maths insists that it's right, then don't doubt yourself, right? Go with that answer. But most likely, if you get like 1 million, then it's probably not right. And you're going to have to go in and check your work right then and there. Okay. But sometimes math problems might be unreasonable, right? They're not completely logical. So if you got like 1,000 apples, that could still be correct. But you would still make sure that your answer makes sense in the context of the problem. This is especially true for word problems. Okay. Another thing you can do is number check. Okay, so let's say the last step of a problem you're doing. All right, like you have to do a ton of calculations individually and get 2 numbers and then add them together in the end to get the answer. All right, let's just say that's how the problem works. From 2 parts of the problem, you got 2 values and you have to add them together to find the final answer. Okay, so let's say you added 1 plus 0.25. And then the problem says you have to round to the nearest integer, which means you round to 1, right? But this means that your answer is probably wrong because the 0.25 that you added, it didn't do anything, right? If you completely ignored the fact that you had to have 0.25 in there, you would still get the same answer, right? The 0.25 didn't do anything to change your answer, which means that it's probably wrong, okay? Because all the parts of a problem are relevant, okay? If you have to solve for two parts of the problem, both parts will contribute to the answer, right? Because let's just say some kid didn't want to do the second part and he only did the first part. If he only did the first part and he got 1, that would be right. But the problem is you're going to have to use both parts. So that when people write the contest, they want to make sure that you include both parts. Both parts are relevant to your answer. So somehow this 0.25, it disappeared in your answer. Then you got to go back and check, okay? Because most likely you did something wrong there. The 0.25 has to matter. Both parts do matter. And yeah, basically, if one part literally got eaten up by this one, because the 1 is so big, the 0.5 doesn't really do anything, right? That literally got eaten up by the 1. So make sure that if this ever happens, then you go back and check your math, okay? Any questions about this? This is a little bit confusing. No? Okay. Someone's asked, I will post the dates in WeChat. Yes, I will do that. All right, so now let's go on to algebra. So the algebraic topics. What you're going to need to know, algebraic manipulation. Sometimes you're going to have a really weird equation. It's going to look like something you've never ever seen before. It's going to be like from Mars, all right? A really weird equation. So you're going to have to make that into something that you do know. And you're going to have to manipulate the equation in a special way in order to get that to something that you do know how to solve. Okay? Then another really essential part is quadratics. Okay? So quadratics basically like ax squared plus bx plus c. This appears a lot. Okay, you're gonna have to make sure that your quadratics are on point. And then sequences in series. All right, so these are the 3 main formulas or area points that you need to focus on for algebra. So algebraic manipulation. So for these boot camps, I'm not going to just plainly review what we did last semester. I'm going to add new things. So as you can see here, we've got more content. So first of all, difference of squares. This one should be a pretty easy one. If you have x squared minus y squared, you can factor this as x minus y times x plus y. Okay, that's how you can factor a difference of squares. We did not cover this last semester, but the difference of cubes and the sum of cubes. If you have x to the cubed minus y cubed, you can factor this as x minus y times x squared plus xy plus y squared. Okay. Sum of cubes looks very similar, except these minuses and pluses, like they swap positions. Okay, right here they swapped. So basically how to remember these formulas is that, as you can see in the final answer, no coefficients on anything. Right, all the coefficients on the variables, 1, right? That's an easy thing. All the coefficients are 1. So that's something you should remember. And also, if we have a difference of cubes, that's a minus right here, which means a minus has to go in x minus y. Sum of cubes, there's a plus here, a plus 1 in x plus y. Okay? And then the next, like, plus or minus that really gets people confused is this one. So basically, you just need to remember that if this is negative, then this must be positive. If this is positive, then this must be the opposite, negative. And the last one is always a plus, no matter what. Okay? So these are 2 formulas that you should remember as well. The difference of cubes and the difference of squares. This is how you can factor them. Okay? And the proof, why do these work? You can just multiply them out. That can be an exercise you could do later. But if you were to multiply these out with the distributive property, you would get x cubed minus y cubed. All right, and then we got fraction conversions. Sometimes you're going to be adding 2 variables and they're both in a denominator, and you can turn 1 over a plus 1 over b into a plus b over ab. The reason this is helpful is it basically takes two fractions, which are separate, right? You're adding them, they're separate, and it turns them into one fraction, which is a plus b over ab. If you do this, it's a lot easier to divide. For example, what if I said, I want to find what 1 over a plus 1 over b is? We know that dividing by a fraction means multiplying by the reciprocal, right? We basically flip it over itself and we multiply it. But we can't really multiply this yet because this is not one fraction. What do we multiply by? We got to turn this into a fraction first. This. So this turns into 1 over a plus b over ab. And then we can multiply by the reciprocal to get ab over a plus b. So these fraction conversions are really important. You can turn two fractions into one, and here you can turn three fractions into one. Okay, these are two formulas you should remember. So you may ask, why do these work, right? Why do these work? Well, when you're adding fractions, what do? Right, let's say I wanted to find 1 over 3 plus 1 over 5. What do I even do in this case? Does anyone want to unmute and tell me? Like, what do you even do? Anyone want to unmute?
So you gotta go find the least common denominator?
Yeah, you have to have a common denominator because you can't just add the denominator, right? This is not 1/8. No, not 1/8. So this is probably very obvious to you, right? This is something that's very obvious. Like, why would I add the denominators? That just doesn't make sense. But a lot of the times, and I made this mistake a ton, whenever you have variables, somehow you just feel like it's different. But this is the same thing. You can't add the denominator. This is not equal to 1 over a plus b. But I did this so much. You don't know how much I did this. This is the one that like really tripped me up. This one is hard. And make sure you don't make this mistake. You can't just add the denominators. If there were regular numbers, you would know. Obviously, you're not going to add the denominators. That's illegal. But somehow in variables, it's just a lot harder to understand. But same thing, you can't just add the denominator. You got to find a common denominator. How do you do that? How do you do that? Well, find the least common multiple of these two. What's the LCM of 3 and 5? 15. All right, so you're going to have to get those denominators to 15. To get 3 to 15, we multiply by 5. So we multiply the top and bottom by 5. That keeps the fraction the way it is. It doesn't change the fraction. And we would get 5 over 15 plus 3 over 15, 8 over 15. That's the right way to add fractions. So when you have variables, we do the same thing. We want to find the least common multiple and get the denominators to the least common multiple. So what's the least common multiple of a and b? Well, to be safe, the least common multiple is a times b, right? So the least common multiple of a and b is a times b because obviously a fits in here always, right? A is a divisor of a times b, and b is also a divisor of a times b. So a times b is the common denominator you want to have. Oops, what happened to my pen there? Okay, so basically you're going to have to get the a to a times b, so times the b on both top and bottom, times an a on top and bottom. You get b over ab plus a over ab. When you have a common denominator, now you can just add the numerators together and keep the denominator the same. B plus a over ab. As you can see, this is the same exact thing as this. Okay, so that's how you would get this formula. So if you ever forget it, you can just derive it on your own, which is pretty cool. The last one, basically the same thing. If you were to apply common denominator again, you would get this formula. Any questions? Cool. Okay. Now we're going to do quadratics. Quadratics. So the most important formulas we have for quadratics are Vieta's formulas. They basically say that the quadratic is ax squared plus bx plus c, and the roots, which are basically the answers to this equation. Right? If we plug r1 and r2 in here, this will work. If the roots are r1 and r2, we know that the sum of the roots, if we add them together, we get negative b over a. If we multiply the roots, we get c over a. Okay. So basically, if let's say we wanted to find, say we had the quadratic 3x squared minus 7x plus 4. So really the minus 4, make sure we're right. Let's say the problem said, oh, what is the sum of the roots? If you had Vieta's formulas, this would be pretty easy. We know that the sum of the roots must be negative b over a. B is negative 7, and a is 3, 7/3. The sum is 7/3. We know that. But if we didn't know Vieta's formulas, you would have to solve for what x is, and then you add those two numbers together, which means you have to use the quadratic formula, and that takes forever, and that's very complicated. So you don't want to do that, and you can actually just find the sum of the roots without even solving for what they actually are. Okay, and sum of the roots is 7/3. And let's say we want to find the product as well. That would be negative 4/3, negative 4/3. So these are really important formulas. Remember these. And then we have something new. I did not talk about this last semester, but the maximum or minimum value of a quadratic occurs at x equals negative b over 2a. We all know that a quadratic, if you want to graph it, it kind of looks like this, right? Let's say we want a quadratic to look like that, or it could look like this, right? In all of these quadratics, we have either a minimum value or a maximum value. All right, and the pattern between all of these is that this maximum / minimum value always occurs at the x coordinate negative b over 2a. So if we go back to our quadratic 3x squared minus 7x minus 4, the maximum or minimum value of this quadratic will occur at negative b over 2a, which is 7/6. So when x is 7/6, we have the maximum value of this parabola. That's what a maximum occurs. But the thing is, remember, this is the x coordinate of the maximum, this value. If you want to find the y coordinate, you have to plug this back into your quadratic equation, okay? So the maximum or minimum value always occurs at x equals negative b over 2a. And a quadratic either has a maximum or a minimum, can have both, right? Because obviously if you draw it, then you will see why that's true. Any questions about quadratics? So this is something new. The maximum or minimum value occurs at x equals negative b over 2a. Don't confuse that with y. To find the y value, you have to find x, then plug it in. Okay, that's a mistake. That's I see quite often. Finally, we have sequences in series. Nothing really new about this. We went over all of these in first semester. So we've got our arithmetic sequence, arithmetic series, geometric sequence, geometric series, and infinite geometric series. Okay? So there's nothing really new here. So does everyone understand what these mean? New people? If you don't, just raise your hand and I'll explain them. Everyone understand? Oh, no? Okay, it's totally okay, right? If you haven't learned this, especially if you're in 6th grade, normally schools only teach this in 8th grade. So I'll go over this real quick. Sequences in series. So what a sequence is, it's basically a list of numbers. List of numbers. But all the numbers have to follow a rule. So what the rule can be, let's say, this is a sequence. Basically, a sequence basically means that it's a list of numbers, but every next number has to follow a specific rule for what that number should be. For this sequence, our rule is basically we have to add 2 to get to the next number in the list. Okay? We call this the next term. We call each of number in this list a term. Okay? So the first term is 1, the last term is 9. And the rule for this sequence is basically you have to add 2 every time to get to the next one. So this is what we call an arithmetic sequence. An arithmetic sequence occurs when we have to add a number to get to the next one. Okay, we have to add 2 to get to the next one, add 2, next one, add 2, add 2. And I like to use this notation. A of n means the nth term. So the first term is 1. So I say this is A1. I say this is A2. I say this is A3. I say this is A4, A5. So an means the nth term. So if we want to find a of n, we take the first term, we add some number d times n minus 1. n is here, right? But d is what we call the common difference. And in an arithmetic sequence, the common difference is the number that we add every time. In this case, the common difference is 2, positive 2. Okay, this is d. And that's n, which is the number we want to find here. Let's say, let's use this formula as an example. Let's find the fourth term of the sequence, 7, right? So we can plug in the formula. A of 4 is equal to A of 1, which is 1, plus 2 times 4 minus 1. And you'll see that this is 1 plus 6, which is 7. So we've generated A of 4, and we know that this is right. Okay, that's why this formula works. And then we've got an arithmetic series. When we take a series of a sequence, the series basically means we're adding all the terms together. We're adding the terms. Okay, so the value of an arithmetic series, which I denote as S of n. So basically the sum of the first n terms is S of n. And the sum of that sum is basically the first term plus the last term divided by 2 multiplied by n. The way to memorize this is that this first part is the average of the first and last terms. Right? We take the mean. Then we multiply by the number of terms there are. So that's the value of an arithmetic series, which basically means we're adding all the terms together. Now I've got a geometric sequence. What a geometric sequence is instead of adding a term to get to the next one, adding a number to get to the next one, we multiply by a number. So this is a geometric sequence. Multiply by 2 to get to the next term. Okay? That's a geometric sequence. So A of n, which is still the nth term, is the first term times r to the n minus 1 power. R is the common ratio. Which is basically the number you multiply to get to the next one. In this case, it was 2. Okay, so that's how you find the nth term of a geometric sequence. A geometric series, if you wanted to add all the terms up in a geometric sequence, that would be this formula. A little complicated, but I'm sure given that you know what these letters mean, it should be pretty easy to understand. And then a really cool thing is we have infinite geometric series. Infinite geometric series basically mean that if r is less than 1, we can produce an infinite geometric sequence. Let's say r is 1/2 here. That means the next term is 1/2, 1/4, 1/8, 1/16. If we take the series of this sequence, and let's say, since it's infinite, we're going to do this forever. At some point, we're going to have a number so small that it literally means nothing. It doesn't do anything. All right. At a certain point, it's going to be super small, and it's not going to do anything. And the sum of all the numbers in this sequence, all the way to the number infinity, the infinite term of the sequence, the one all the way on the right. If we add all of them together, the sum is the first term over 1 minus r.
What do you mean by common ratio?
Common ratio is the number we multiply every time to get to the next one. Okay?
Okay.
Right? Does that make sense?
Yes.
Cool. So infinite geometric series, the way this formula works, it's actually based on this one. Because basically, if this series is infinite, then n is infinity. So S of infinity is A of 1 times 1 minus r to the infinity over 1 minus r. If r is less than 1, then it's a fraction, right? And if we take a fraction to infinity power, we're multiplying that fraction by itself so many times that it basically equals 0. So this term literally disappears. And you can see this is our infinite geometric series formula. If r is greater than 1, then this formula won't work, right? Because if we put it in here again, we get a1 times 1 minus r to the infinity over 1 minus r. If r is greater than 1, then r to the infinity is going to be huge. It's going to be an enormous number. Okay, so that's not going to work. Any questions about sequences in series? Yeah, so I have to do, sorry if you've been in this class before, but this is good review, okay? Make sure that you understand these concepts fully ahead of the competition, okay? But since we have new students here, I do have to go and review some of these concepts again, okay? That's it, let's do some problems. We don't have that much time to do problems, but we're going to do some problems now. This is a problem that should be new to all of you, actually. This goes over the new concepts we learned with the quadratic. Okay, so I'll give you guys 3 minutes for this problem. So as I like to do in this class, whenever you get the answer, you private chat it to me, and then I'll let you know if you're right or not. Good? All right. 3 minutes. So calculator is allowed on part B, but not part A, okay? Part B, nearest 10th, please. Part A, exact. All right. Okay, so part A, amount of time in the air. So how long is this football going to be in the air? So that's actually, there's a certain amount of logic involved in this now. So it doesn't really, you don't really memorize, oh, the equation of a football, the, the amount of time in the air is given by this formula. No, we don't have a formula. So we got to reason out, what is the amount of time in the air? Well, let's think about what it means for football to be in the air. When it's in the air, what's its height? It can't be 0, right? When it's on the ground, its height is 0. If it's in the air, then its height is non-zero. So when it falls to the ground, it hits the ground, when its height is 0, then it has finished his travel and it's on the ground now. So I want to find amount of time in the air basically means when does the height equal to 0, right? Because when the height's 0, then it's on the ground, it stopped being in the air. We can imagine if we had a timer, then the timer would stop right at that instant, which means that h is 0. We're going to find what times work with this. We're going to have to factor this on the right side. My pen is not 16t plus 49. Two solutions for this are t equals 0 or t equals 49 over 16. T obviously can't be 0, right? The reason t equals 0 appears here because the height was 0 when the ball was kicked, right? The height was 0 when the ball was kicked, but that's not the number we want, right? So this answer, this solution, we don't want that. So the actual answer is t equals 49 over 16. The unit was seconds, we would say seconds, okay? Part A. Now part B, what's the maximum height? We know the maximum height occurs at the x value, where x is negative b over 2a. That's where it occurs. All right? But we don't have x in this equation. This is not a normal quadratic. We have h and t. H is our y value, actually. If we pretend this is a y value, then t is the x value. So if we pretend t is x, the maximum occurs at t equals negative b over 2a, which is 49 over 32. But this is not the maximum height. This is the time when the maximum occurs. Okay? This is when the maximum occurs. To get the actual maximum height, we have to plug this number as t into the equation. And this gets a little complicated if you want to do it by hand, so that's why I allowed calculator for this. And if you plug that in, you would get, let's see, my calculator says 37.5, let's say it was feet. Part B. Any questions? No? Fantastic. Okay. This one's really interesting. The perimeter of a rectangle is P. Prove that the maximum area of the rectangle is obtained if the rectangle is a square. Right? I'm sure a lot of you should know that the area of a rectangle is maximized if it's a square, right? If we had a rectangle that's really, really flat like this, 0 area, but very large perimeter. So can you prove that with your knowledge of quadratics? I'll give you until the rest of class. We didn't finish all the problems we were supposed to do today, but that's totally fine. We will do them next time, okay? Because I had to go through the general tips for the first half of class, because we don't really have that much time for these problems. So give this a try. I'll give you until the end of class, which is 3 minutes, to prove this. Okay, so I'm going to go over this one now. I'm sure a lot of you already know this is true. The maximum area is obtained if the rectangle is a square. But it's really fun to know that these actually work if you do the math. So how do we know this is true? If we set x as one of the sides, let's say the other one is a. Okay, I don't want to get you confused. We know that 2a plus 2x must equal to p, right? So let's find a in terms of x, because we know that we want to get the area as a function of x. Okay, so what is a in terms of x? Let's divide by 2. A plus x is p over 2. A is p over 2 minus x. This is a. We know that the area is x times a, x times p over 2 minus x. We literally put this and substitute it in as a. If we multiply this out, it's quadratic. We know the maximum value of a quadratic occurs at x is negative b over 2a. B is p over 2. A is negative 1. So we got negative p over 2 over 2 times negative 1, which is p over 4. So when x is p over 4, we get the maximum area. And recognize that if x is p over 4, then the area, then the shape must be a square, because a is p over 2 minus x, which is p over 2 minus p over 4, which is p over 4. So a is equal to x when the area is a maximum, which means that it must be a square. All right, I think that's pretty fascinating. So actually, instead of doing the rest of the problems next time, we're actually going to have to move on because of the time that we have, because we have 3 weeks until the Mathcounts competition. So I'm going to be putting the rest of the problems as a worksheet that you will do as homework. Okay, cool. Okay, then you can leave now. All right, so I hope you enjoyed the first class. We'll be doing this. We'll be doing boot camp until the Mathcounts chapter competition. We'll see how many of you pass that. Hopefully, a lot of you will. And then we'll see what we'll do after that. Okay, so after that, we'll focus on more about learning new concepts. Okay, because right now we're almost there at the competition. Ideally, I want to go do some more review for you guys. All right, so if there aren't any questions, I'll see you next time. All right, bye.